Newton's second law states that the sum of the forces on an object is equal to the acceleration of that object times the mass. But what if instead this object is actually two objects? Do I now need to consider the forces that are acting between each of these parts? Or what if I consider the object to be made out of even smaller parts? I can take it down to its smallest components and consider the interactions between all of the atoms in the object. This seems like an overwhelming number of forces that I'm going to need to calculate to just define the force on this object, but I never seem to calculate this many forces. Why is that? All of these forces between the atoms in the object cancel out because they are Newton's third law pairs. If both objects are within the system, since a Newton's third law pair of forces is equal and opposite, the total force is just zero. We call these internal forces. That is, forces that are acting between a pair of objects that are both within our system. On the other hand, external forces, forces that act on an object within the system by an object outside the system, are what we need to consider for our calculation. We could be more precise about Newton's second law and say that the total external force on a system is equal to the system's acceleration times the system's mass. Let's look at an example of how the selection of a system will affect the forces that we need to consider. I have 3 blocks, I'll call them 1, 2, and 3, and a force that's pushing block 1 to the right. We'll first take a minute to look at notation. We will write the forces as F12, and this means that it's the force exerted by an object 1 acting on an object 2. In this example, I have pairs of forces between each block, the interaction between blocks 1 and 2, and the interaction between blocks 2 and 3. Let's look at the internal and external forces on the system if my system is made up of block 1 and block 2. I have this external pushing force, F external, that's acting from the external pusher on block 1. Blocks 1 and 2 are interacting with each other, but these are both within my system, so these are internal forces that I do not need to worry about. And finally, block 2, which is within my system, is interacting with block 3, which is outside my system. The external force here is the force that is acting from block 3 on block 2. Now, we know that the two forces that are relevant to calculating the motion of this system are the external pushing force and F32. If my system is instead made up of blocks 1 and 3, block 2 is now part of the external environment. Can you figure out what the internal and external forces are? In this case, the external forces to the system are the external pushing force, F external, F21, and F23.